Today we will talk about full subtractor. So in full subtractor, the figure consists of the minuend and the subtrahend. So if you look at the full subtractor, it has one minuend, that is an, and the other subtrahend, which is bn. Along with that, we do have other input, that is nothing but the borrow. And the output of the full subtractor has one is the difference, and the other one is nothing but the borrow. So this is the schematic of full subtractor. In full subtractor, if you look at the truth table of the subtractor, so it has the minuend and the subtrahend. So let us take an example. Suppose if you are subtracting 1 from 0, so there will be the difference will be 1 and there will be borrow. So this 1 will be the difference and this other one will be the borrow of the subtraction. Now if we'll take one example of the full subtractor, which has one is the minuend and the other is say subtrahend is b. So now if we look at the truth table of it, so the truth table of this will be like this. There will be a will be one of the input, b will be the other input, and along with that there will be borrow. So if we try to plot the truth table of this, there will be difference element and the other one will be the borrow. Now the output of the full subtractor will be difference and borrow. So now suppose a will be 0, b will be also 0, and suppose the borrow element is also 0, so the difference of this will be 0, along with the borrow will be also 0. On the other hand, if we take the subtrahend will be say 0, minuend will be 0, and if we have the borrow element, that is 1, then the difference of this will be 1 and the borrow will be also 1. So this indicates that if we subtract 1 from binary 1 from 0, then the difference will be 1 and the borrow will be 1. Now we try to complete this truth table with the different elements. So as we know that in the truth table while drawing, we will pair the combination of the 0, 1, 0, 1, 0 and 1. So this will be the first row, that is the borrow, and we try to look for the other elements, that is 0, 0, 1, 1, 0, 0, 1, 1. Similarly, we will try to write the other elements of A, that is 0, 0 and 1, 1, 1. Now we try to complete this truth table with the difference and the borrow. So now we look at the first element, as I told earlier, that will be 0, 0, 0. So difference will be 0 and borrow will be 0. Now if we have the 0, 0, 1, 1 is the borrow, then difference will be 1 and the borrow will be 1. And now if we have 0, 1, so if we are going to subtract 1 from 0, so that will be difference will be 1, and since borrow is 0, so there will be combinations of the difference as well as one borrow, which is generated by subtracting b from a. Similarly, now we look at the subtraction of 0 and b. So now 0 from 1, if you are subtracting, that combination will be 1, and again we are subtracting one more borrow, so the combination will be difference will be 0 and there will be one more borrow is generated. Now look at the other case. In the other case, now we do have the combination of 1, 0 and 0. So the difference between 1, 0 will be 1 and the borrow will be 0. And now look at the other element. Now 1, 0. So this difference will be 1, and then 1 we are subtracting from 1. So the difference will be 0 and borrow will be also 0. Now look at the other element, that is 1 minus 1 will be 0. So difference will be 0 and borrow will be 0. And then 1 minus 1, then the difference will be 0, and 0 minus 1, then difference will be 1 and borrow 1. So this is the truth table of the full subtractor. Now in order to realize this full subtractor with the help of the Boolean algebra, we need to carry out the Karnaugh mapping. So we'll try to draw the Karnaugh map of this truth table. Now we know that this Karnaugh map will be having the three elements, that is A, B and borrow. So I am drawing now the Karnaugh map of this difference element. So now K map of, say, K map of D. So the K map of D looks like this. We do have the elements, that is A, B, and this is the borrow, that is I am writing BO. Right? So now we do have here B0 bar and B0, and these are the elements of the Karnaugh map. So we do have here A bar, B bar, then we do have here A bar, B, then A, B, and then A, B bar. So now we try to put the elements of the difference in this Karnaugh map. So the elements are 1, 1, 1 and 1. So now if we try to look at this K map, there will be 4 ones. So the Boolean expression for this difference will be like this. So this difference Boolean expression will be D will be equal to A bar, B bar, B0 plus A bar, B, B0 bar plus AB, B0 plus A, B bar, B0 bar. Now we try to simplify this. So if you are going to simplify this, so we try to use the Boolean algebra. So if we try to simplify this, this will be simplified like this. So this will be A0, B bar, right? So this will be A bar in bracket B bar, B0 plus B, B0 bar plus here we take common of A, that will be B, B0 plus B bar, B0 bar. So it seems that there will be combination of XOR gate between A and these combinations of this. So if we take B bar, B0 plus B, B0 bar as one of the element, that is X. So this combination looks like this: A bar X plus A X bar. So it indicates that this will be combination of A bar A XOR with X. Along with that, this will X. So this X is already the combination of B XOR with B0. So the difference element, that is D, will be equal to A XOR B XOR B0. So the difference of this will be recorded as